Today I'm going to be solving this trie problem, implement trie. A trie is essentially a type of in-array tree that is used to store strings. It's a tree data structure used to store and retrieve keys in a data set of strings. So it's often used in autocomplete and spell checker. And for this problem, I want to be implementing the insert, the search, and it starts with our functions for the class trie. So what this algorithm is wanting is that I'm going to create a trie node class that's going to contain a dictionary, self.children, and this is essentially going to be storing all of the trie strings with the same prefix in the trie. Then I want to have an ending Boolean flag that's going to mark whether the string is at the end of a word. So I'm going to set this equal to false initially. Now I have my root node that I'm going to set equal to a trie node, an empty string, because at the root of every trie would be an empty string. Now I'm going to create the insert function. The insert function is going to instantiate a root node. And what I'm going to do now is I'm going to loop through the word. So I'm going to loop through the word and get each character of the word. And I'm going to have an if statement that's going to test whether the char is in my node.children. If it's not in node.children, I'm going to create it. I'm going to create node.children char and set that equal to a new trie node. Now I'm going to set my node equal to char. And I'm also going to set my my ending flag. My node dot is end. I'll set that equal to true because after when I reach the end of the word, it'll be the end. It should be true. So this is my insert function. Now I'm gonna have my search function where I'm gonna be essentially looking through my trie, and I'm gonna be searching for the word in it. So what I'm gonna do now is I'm going to have my root node, and I'm going to be looping through my word again, and I'm going to checking if my char is not in node.children. If it's not in it, return false. And then set my node equal to node.children char, and I return whether I'm at the end of the node. So my logic for doing this, if the character is not in the trie, the first character is not in the trie, you know that the word isn't going to be in a trie, so you have to return false. And if it is, then you want to keep on searching through the children of the node, of the trie node, and just going down. And if you reach the end, if node.isEnd is true, then just return that you reached that the word is definitely in the trie. So now what I want to do is my starts with function. My starts with function essentially returns true if there is a previously inserted string word that has a prefix, and false otherwise. So you just want to be seeing if the prefix is in the trie. What I'm going to do now is again I'm going to be instantiating my trie, and what I'm going to do now is I'm going to be looping through my prefix, and I'm going to be comparing if my character is not in my trie, in other children, then I return false. And if it is, I'm just going to be setting my node to the value of my children key, and I return false if return true if I reach the end and the prefix is in try. So the algorithm runs faster at 26%. The runtime complexity of this would be O of n, because I'm just inserting, searching, and start, and it'd be O of n. And space complexity of this would be O of n, where n is the number of characters in a word. Thanks, guys.